Welcome to another episode of DLT's ContinuousX podcast, where we attempt to solve for X in the SDLC equation. My name is Rick Stewart, DLT's Chief Software Technologist, and joining me is my co-host and colleague, Mike Fitzurka, Senior Sales Engineer for our Application Lifecycle Technologies. Today's guests are John Miller and Dan Minnell from D2IQ. John is a public sector principal sales engineer, and Dan is the field sales engineering manager for commercial and public sector. Welcome, John and Dan.
Glad to be here.
And as our viewers know, this forum is a Q&A style, but what John and Dan don't know is an incorrect answer will cost each of you time sitting in a remote gas station line, filling up our fuel tanks somewhere in a rural location in Virginia. So answer carefully.
And you will have to wait till gas arrives.
Can I bring plastic bags?
Yes, you can.
Awesome.
So let the questioning begin.
Excellent. Okay. I think this will just go to each of you or to whoever feels like they want to answer. I think it's safe to say Kubernetes certainly seems to be the platform of choice for modern architectures, given its ability to orchestrate and manage workflows and cross several hosts and multi-tenancy. Where do you see this expansion continuing in the near?
I picked Dan.
Yeah, I was going to say Dan.
Good question. You know, it's an interesting time, and Kubernetes is an interesting technology because this is one of the first times, at least in my career, where there hasn't been a single company that has been driving the agenda of a specific technology. Yes, Google and others are having their influence, but when you look at mainframes, IBM was the driving force. When you look at PCs, IBM and then later Microsoft was the driving force. With virtualization, it was VMware. But with Kubernetes, you truly have a community-driven technology that, in reality, who knows where it's going to go tomorrow? Great. It started off being built for microservices that were ephemeral in nature until somebody decided, hey, I can put Kafka and Cassandra on this. And now we see things like data services, machine learning, and many other workloads that were never considered. One of the things that I really see happening with Kubernetes is it's going to turn into as much of a software distribution mechanism as much as an infrastructure mechanism. Everywhere I'm going, I'm talking to people and they're saying, I'm running single node Raspberry Pi clusters on my shop floor. And how do I effectively deploy software to that, considering that it's a single node Raspberry cluster? Where's it going to go from here? Goodness only knows. John, I'll turn it over to you for a second for some of your thoughts.
Yeah, no, I concur with Dan, right? A lot of the things that we're seeing is, there's some bright ideas coming down the pike where, putting it on aircraft, putting it at the edge, right? Forward deployed troops, things like that we never thought where we, today typically gather data, right? And do post-mortem analysis on this stuff, right? But now we're talking about doing this real time, everywhere, right? Not simply just at an infrastructure level, but literally out to the outer reaches, right? So if we're, got troops in harm's way, they're actually, technically able to put these on a backpack and do stuff real time. So I see a lot of cool things coming down the pike in terms of what it's going to bring in terms of what I would consider application, delivery advancements, right? Like Dan talked about. It's not the old method of point, click, and send some software updates out. It's really real time, compile, build, and get this out up and operational. And so it's really going to make a huge difference in a lot of the arenas that we're working with inside of DoD. So I'm excited to see where it goes.
That is a perfect segue, John. Dan, you've escaped question number one. When we're talking about addressing large-scale DevSecOps, like we're talking about in the public sector and your environments, with multiple tenants and various projects, the simplistic idea might be to give each tenant its own cluster. But is that truly the best multi-cluster strategy? What else should agencies consider when facing this problem?
Oh,
John, that goes to you.
Yeah, that's a great question, right? So, one of the things that we've been doing, from a company perspective, and kind of looking at the ecosystem of Kubernetes, right? So there's a lot of things going on in DevSecOps, right? From if you kind of break it apart, you've got Dev, you've got Sec, and you've got Ops, right? And they're really all separate concerns, and they look at things differently, right? If I'm Ops, I'm looking at, do I need multiple clusters for high availability? How do I do disaster recovery, right? If I'm a dev, I simply just want to deploy a workload and be able to have, a way to test my application in production or non-prod, right?
Right.
But when you really look at it, there's a lot of factors that come into play. And some of the things that we've been toying around with is an auditor's guide, right? In terms of what's my cadence for this maintenance? And that's really going to kind of shape, where this goes. Dan and I were actually just talking about this morning where, maybe I have multiple clusters, but some really are, in a space where updates are very infrequent or, they're very stable. And so maybe I want something that's on a longer cadence in terms of maintenance, but I need something that's, more readily patched or up to date with bleeding edge technology capability, right? So I might have multiple clusters for that reason, right? But there's not one, strategy that we go down. It's really kind of understanding, what are your pain points today in terms of how do I assess what I need? Is it specific hardware, right? Is there requirements in terms of, hey, I need GPUs or specialized capabilities or things that are region-based, right? Or maybe I need to do topology-based workloads, like really deploying these things by being able to select the geolocation that this workload goes to, right? So that may determine, hey, I need multiple clusters and how big are they and how are they centrally controlled and things like that. So, that's really where I've kind of seen some of the DoD initiatives get very focused on multi-cluster management and trying to understand how to approach that subject.
Yeah, I think with the multi-tenant as well, with the implementation of good security at namespace level, you can have workloads, running right next to each other and feel confident that, the security will separate them accordingly so that you can move your workloads around where you, as you said, John, where they need to be running.
Right. And you bring up a great point, right? Is in terms of, hey, how do I address those security concerns from that security perspective? And the platform provides the ability to apply policies, right? So they can be dynamically changed, they can be enforced, they can be, lessened. So it's such a dynamic arena in terms of what you're doing at one level is really affecting things all the way down into the infrastructure level. So it's interesting to see how people really address this from, hey, this is the way I've done this for 20 years. Now I need to rethink, and can I apply those same principles to this arena? And it's interesting to see how people approach tenancy. So,
it's interesting. It's people tend to look at things in a binary way. That's the world we live in. And it's not mutually exclusive. Multi-tenancy versus multi-cluster, it doesn't have to be a choice either way. I think the original question should be, what's more important is how I provide people, because that's people are the ones who build things and people are the ones who use services. People need secure, comfortable access to resources in which they need to do their job. So for developers, that might very well be a multi-tenant environment on a single large cluster running in the cloud where everybody's name-spaced and has their own quotas, have their own network policies, keeping everything in line. Yet in a forward deployed area, simplicity may be of paramount concern, where I may want to say, you know what? I can't worry about any of that. One cluster per environment or one cluster per person based on the requirements and the trade-offs back and forth between resiliency, reliability, and repeatability.
Agreed. And I think when you get down to like performance and load environments, you probably want to keep those into a separate cluster and make sure that you're not bringing down, operations across the board. kind of defeats the purpose for DevSecOps. But that's really the only real argument about separating a pre-prod environment.
One thing I would say, though, is if you look at technology adoption or infrastructure adoption through history, it goes in these life cycles of getting things into the hands of a few people. That leads to widespread adoption. Mm-hmm. That leads to chaos. That leads to overcorrection the other way. Yes. And then you have this ping pong match and fight between operations and applications, where what you really need is a way to give people what they need, or actually give them what they ask for, more importantly, but then have the data behind the scenes to actually say things like, you asked for an entire cluster. I don't see you actually doing any inside-outside or outside-inside communication, or you asked for an extra large environment, but what you're really using is a medium environment. I've given you what you asked for, but now we have data to right-size that environment or replatform in order to serve the future needs of the people, the organizations, and the workloads.
Go ahead.
Oh, go ahead.
Well, I was going to say, I've always noticed the same flux in making a smart client and a dumb client. And we got to centralize everything. Everything needs to be central. No. We need to make things smarter. Now let's have everything in a data center. No, now let's move computing to the edge. It just constantly flux on back and forth, and it's always when it's out on the edge. Security. How do I manage all of that? But then when you bring it all central, well, then you're not getting that diversity.
It's interesting. There's an old quote, and I forget who it really came from. The short version of it is, you can't manage what you can't measure. But the long version of it is something like, the definition of a broken system is the one I can't measure and improve upon. And this is what we see when we see this knee-jerk reaction of back and forth and overcorrection, where I need 12 PCs, you can have one. I need 3 servers, you can have none. Or I need a VM with 8 CPU cores and 64 gigs of memory. Okay, corporate policy states you can have 2 CPUs and 4 gigs of memory, unless you can prove to me you need more.
Exactly. And that kills projects.
And quite honestly, that's what led to the public cloud in the first place. Let's be honest. It was application people needed access to resources. Internal IT processes were too slow or too rigid to get the work done. They had their own funding, so they said, you know what? You're not my only provider. Right. I've got these guys over here that I can go to as well.
Right.
I love shadow IT.
And that's yeah. And you all brought up a good point, right? Is in terms of data too, right? And the adage that Dan was saying, right, that we saw that early on, right? It was cloud first, and then we've got a lot of people that are now going more cloud smart strategy, right? Let's bring the compute right in close to the data as opposed to just pushing it all out, right?
Yep.
Once I get it into a cloud provider, it's hard to get it out. So, we're also seeing a lot of ask, right, in terms of how do I bring AI ML into my on-prem environment, in my classified environments, and work on the data that really means something to me instead of trying to, create things outside that, aren't going to produce the results that they're looking for. So there's a lot of movement.
Yeah. There's, in the past, there's been this, this bifurcation between long-running services and batch jobs, and never the twain shall meet.
Right.
What we're seeing with Kubernetes is, because of the fact that it's software defined and the fact that you can provision or deploy and pull back so rapidly with containers, it's bringing this, it's bringing the concept of transient workloads, things like training and tuning, things like jobs for analysis. It's bringing those more to the user as opposed to being just a back-end processing thing. And it's more, how do I orchestrate that complex workflow as opposed to how do I deploy a web server?
Exactly. Right. Good point.
I think we've been been around. Let me bring back to what we were talking something about multi-tenancy, and that I think our audience understands the importance of monitoring Kubernetes and its impact on the operations side of things. Are there a different set of challenges or additional challenges when you're monitoring specifically for multi-tenancy, or is that just another namespace to Kubernetes?
John?
Oh, sure. I was going to let you go, Dan, since I started laughing. That's all right. Absolutely right. It's when we look at it, there's a few things inside of this space that we want to monitor, right? So it's system level. What's going on at the system level, right? Because at the core of Kubernetes, there really is a process running on the local system, right? In a traditional sense of, hey, I've got a daemon process running on that box. How do I monitor it, right? The neat thing about Kubernetes is with the advent of the namespace, which was really grew out of C groups and namespaces at the Linux container capability, right? And now we've bubbled it up into Kubernetes and given you a place to do true multi-tenancy inside of an orchestration tool. But every one of those tiers, right, are bubbling up into Kubernetes, and you'll see the ability to customize that and actually have that data recorded inside of Kubernetes. So whether it's events or whether it's custom policies that fire, all that stuff is getting monitored throughout the system, right? And it's still in the traditional sense, it's a log file. So people are going to, be using the tools that we've had in place, whether it's Prometheus, Grafana, right? But to do that alerting and monitoring, but from a sense of how do I simply do this, right? I've got a lot of clients that come to me and say, well, we've got a lot of developers that need to look at their logs, right? And understand where they're at. We've got security that's also asking for, segmentation of the logs. So now you're bringing in that multi-tenancy into monitoring where I've got a central system that's logging it all. So security doesn't want everyone seeing everybody's data, whether it's PII or something that's sensitive, right? But those teams still need access to it. So monitoring is very key, right? And Kubernetes does a pretty decent job of creating thousands of events, right, around the system, whether, again, it's at the system level or bubble up to that application level. So it's really kind of neat to see what you can capture and what you can gain, right? There's a lot of capabilities being built around optimization and efficiency, right? That's one of the things that we look at in our platform, right, is how efficient are your workloads running by using those monitoring techniques. So that's, key to keeping this agile and not over provisioning, but not underutilizing systems either, right? So it's key to a lot of things from a holistic approach.
I think it levels the playing field for operations over a heterogeneous environment with many different languages and workload structures and messaging queues. It all kind of levels it out because you're looking at one platform that has lots of different tagging and labeling and metadata that you can do a lot of monitoring at one centralized location. Kind of evens things out.
Yeah. It's interesting though. In many ways, Kubernetes has these things in there to make itself easier, but Kubernetes by itself, as we go through this abstraction of one layer, another layer, it used to be I have one application running on one server or a few servers plugged into one network port. And if you wanted to go troubleshoot that application, maybe I'm showing my age here a little bit, but you go and plug in the sniffer or you look at the agent on that server and you start doing the protocol analysis and you look at your TCP time and it's like, oh, here's my problem right here. I mean, that's where I started. You had a one-to-one relationship, infrastructure to application. Right. But as we move to virtualization and then to containerization, and you start to abstract away the underlying architecture, you have this many-to-many relationship building up, many users accessing many different components, microservices. So there's things you need to do ahead of time to ensure that things are going to work. One of them, thank goodness, Kubernetes and the whole Agile and DevOps movement has done is they've broken away the tap point, if you will, from the actual application code. So each independent pod or running application can have its own instrumentation point separate from the application. And I know this is getting detailed into things like service meshes, but what it really allows you to do is every container has a sniffer on it nowadays.
Right.
But the other thing that organizations need to be able to plan for is you're no longer having this linear test validation process where if one works and I have twice as many users, I just need two. It's like you've got these interlinking and these intermingling of workloads that you really need to put forward some form of massive stress testing upon it to find out these real world situations, because just sitting there and executing 5,000 of the same transaction against a single system isn't going to do it anymore. You need to do more, mixed workload testing or validation to validate that a mix of workloads are going to scale in your environment to achieve the mission.
And not to mention chaos engineering or taking workloads down and seeing how the overall system is impacted. So I think that's the next hurdle that's going to be monumental.
I have personally nicknamed myself Chaos Monkey at our organization because I'm the guy who says, let's see what happens when I push this.
Oh, right, wow. Okay. You're that guy.
I'm that guy. They come back and say, well, we don't support doing it that way. It's like, yeah, but I just did it. What's your answer to that?
There's a button right here. I pushed it.
I pushed the button. Well, don't push it. Oh, that ain't going to work.
All right, I'm going to go to the next question. This is kind of similar, Dan, to what you were kind of mentioning. Many of our public sector agencies have additional challenges in dealing with like air-gapped environments, like highly secured environments, high-low sides, tactical vehicles, IoT devices. How can a cluster resource be addressed in these environments?
So what do you mean by a cluster resource? I'm curious what you mean by that.
A cluster running on various different environments that don't have access to an internet, that you have to maybe manually load an image from a registry. Those types of challenges that are challenges regardless of what operating system you're running on. How does Kubernetes or overcome that, or how is it easier?
So I would answer that the same way the Army and other military services answer that, is by having a common platform. Perfect. You look at a Humvee or a Huey or an M4. They can all serve different purposes within different operating environments. A Humvee today may be an ambulance. Tomorrow it may have an IR targeting system on it. You're swapping in and out the componentry on top of the base platform. And that's what I think is really critical in Kubernetes, is to provide a base platform that people know how to operate, whether it's at a forward operating base, in a data center, at the edge, on an F-18. I'm going to use the F-18 because I'm from St. Louis and that's where they come from. But it's about providing a consistent operating experience no matter where you are, so that anybody who knows how to use Kubernetes can use it anywhere they need to go. Perfect. That's one of the things I see.
Right. John, anything to add before we move on?
Yeah, no, I think, Dan started to go down that path, right? And I'll kind of pick up, right, is, where I've seen this in this environment, right? I spent 20 plus years supporting the U.S. Navy as a contractor in this area, right? Born and raised. So I know contracting very well. It's pretty much the only job I've ever done. But in those environments, right, this really breaks the traditional mold of, let me segment my application, right? I've got a specific system I'm going on, right? It requires a specific OS and I have to do things this way, right? And so, that's what really virtualization was helping us with, was break that mold of, hey, now I can virtualize a system. I don't have to worry about if it fails or dies, I'll just restart another instance of it, right? So we've been gradually getting closer to this, but where I've really seen this happen is, I did a lot of work on board, submarines, right? And so we write a lot of software, and it was always air gap. And there was always that, hey, we forgot this or we forgot that. And what do we do now? And how do we get it out to the boat that's under the ocean? It just doesn't work, right? So the advent of, like you mentioned, registries, things like that are key to Kubernetes makes that so much easier. And we're looking at taking things where they've been slotted for years, right? These applications were slotted for these specific programs, right, on board, where we underutilized hardware for years, right? And it does have some direct applicability to how ready are you, right? Can I execute a plan in a larger op area, right? If I've given more shared resources, right? Where today I might be limited. And so, you have to look at it from that perspective as well, as like, hey, as we go into these air gap environments, what is Kubernetes really bringing me? It's bringing me shared resources, potentially increased capability, a generic way to deploy, right? And that's one of the things that we've done, right? People ask me, hey, I want to do AI ML on board a sub, which we're, helping the Navy do. They said, well, what do I need to do? I'm like, well, here we have, a set of images. It's roughly in the, order of magnitude of like 80 gigs worth of data, but here's everything that you need in the kitchen sink. Simply deploy this right on the system. Now you have everything ready to go. So, we're kind of building that secure supply chain to get into these environments. And that's what I think you're going to see as part of this whole DevSecOps approach that trickles down into these air gap environments. How do I ensure, right, that those images are secure? They've been scanned. I have some provenance with them that I can bring and put into the system and now support, right? We have to support it. It's not something that, hey, we'll wait 10 years until that sub comes in to update its information. No, I want to be able to give somebody now the capability to simply push a container into the registry. When that boat docks, they can simply update and move on, right? And I think that's what you're going to see happen across a lot of things that run containers, whether it's, embedded systems, backpack laptops, like Dan said earlier, it's Raspberry Pi. I can, there's portable GPUs now that are in the same size. So a lot of capability, a lot of different form factors, but now you've gotten rid of virtualization and now it can run these things natively on these platforms, which is hugely instrumental in helping orchestrate, and give capability back to, the warfighter and DoD and things like that. So I'm excited to see where some of the next advances are.
Well, go ahead, Dan.
No, I was just going to say, it's interesting. We bring up the concept of resources and the concept of, because Kubernetes can allocate or deallocate, malloc or realloc, resources at will and almost nearly instantaneously, it almost goes into asking the question of what is the cycle time that I really need to support of getting data off and getting new packages on. For instance, the cycle time of an Ohio-class submarine when it comes into port is going to be a little different than an F-18 when it lands on the deck of an aircraft carrier and needs to get retasked to a new sortie and take off again. So what do I do with my compute resources in order to grab the right amount of data off, push the new workloads out so that I can almost do just-in-time supply chain management?
Right. And that's where I was going with that. Dan, it was a perfect segue with the microservice environment. With smaller workloads, more precise, easier to update, easier to test, easier to get changes out to the field quicker, which is the goal, is to get the changes out quickly on speed of need, as opposed to speed of your department policies. Yeah. So,
well, perhaps you can run down the hall with the disk in your hand and get it.
Well, this goes back to a comment John made earlier about geolocation, different types of resources, GPUs, CPUs, memory, what have you. One of the things that makes our people so effective is the situational awareness that we have in the field of not only where the enemy is, but where the friendlies are as well, and being able to bring resources to bear. That's one of the great things I think that Kubernetes provides, is everything's a resource that can just be brought to bear on a specific problem, either at small scale or at large scale.
Right.
There's going to be trade-offs. There's going to be cost-benefit analysis that needs to be done, but there's really nothing to prevent you from doing this massive scale. If I need to do a data analysis to find an answer to a question in 10 minutes, well, if that's a critical answer I need to have, I have the ability to bring the resources to bear. Those are things that we've helped people like Twitter, Airbnb, and other U.S. government organizations solve those types of problems.
Fantastic.
Well, I don't think anyone has to wait in a gas line.
Yeah, I think
No, I think we got it. We're right on with the answers today.
I think you and I have to wait, Mike.
Yeah.
John, what was the statement you used earlier that describes us?
Oh, stupid Kubernetes guys. Kubernetes
We are
guys.
stupidly enthusiastic about this.
Yeah, there we go. That's it.
Fantastic. Well, we end every podcast with a lighthearted question, so nothing too serious here. But if and in theme with the title of the show, if there's something that you could do continuously or have as a continuous resource in your life, what would it be? And we'll start with Dan.
Attention.
Ooh, that's a good one.
Attention
I think
seeker,
John
huh?
knows I am, if you ever remember the movie Up, I am that dog, squirrel.
What?
That just means you have interest across the board for everything.
I have many interests that change on a moment-to-moment basis.
Squirrel.
And John?
Oh man, probably I would say lucid thoughts, because I've got so many ideas around Kubernetes that there's a lot of things that I would love to spend the time on doing and developing. It's like Dan said, I think you can tell talking to us, and we're very passionate about this. We do love Kubernetes, right? We've been in the industry for a long time, and so this is definitely something fun, right? My goal is, at least leave the computer every once in a while, feed myself and get some nourishment, and then come back. But always looking to what the next big thought is that somebody helps, set my mind to expand Kubernetes. So,
And that's the beautiful thing about Kubernetes. There's nobody to tell you no.
Yep.
Well, that's awesome, fellas. That'll about do it for this episode. We thank all you viewers for your time and attention. And special thanks to John and Dan for the information you shared with us today as we continue to solve for X in the SDLC equation.
Awesome. Great. Thanks.
Thank you for having us. This was fun.